Alrighty, folks, we are back. We are back. Come on now. Come on. What are we learning today? We are learning some functional programming in Python. Look at this thing. Look at this thing. Come on. Stay up. Stay up. Oh. I'm about to tighten all the doohickers when I get a sec. Let me turn it up a bit. So what do we learn on the last one? We built the book bot and things. It's just been cruising right along, right? Just learning this Python stuff, and not only in a way where we're learning about Python as a language from syntax, but also just obviously classes, the OOP stuff, and encapsulation, and just learning stuff in a real proper approach. So that's been really fun. Okay, so now we're diving into functional programming. So traditionally that's kind of coined object-oriented programming, where we have our classes, we have our functions and methods associated to that. Let's learn about functional programming. I transparently I don't know the differences. I don't, maybe I'm functional programming at times, maybe I'm doing object-oriented stuff. So let's figure out the granularities together. It's going to be a good old time. So functional programming is a style or a paradigm, if you're pretentious. I love bootstrap. I love them. I think they're great. So it's a style of programming where we try to compose functions instead of mutate state, updating the value of variables. So hold on, we try to compose functions instead of mutating state. Interesting. So functional programming is more about declaring what you want to happen rather than how you want it to happen. So this is all new to me. So imperative or procedural programming declares both the what and the how. So examples of imperative versus functional programming. So imperative, we have a car, we create the car, we add the gas, we clean the wind. Functional programming is we just invoke a bunch of functions nested in each other. I'll be honest, I think this whole thing is pretentious. Like, who gives a flying, I'm trying to keep my language PG here, but who cares if your syntax looks like this versus this, right? Like, I don't know. I hate to talk crap about engineers because I'm teaching engineers, But sometimes it's like we're doing all this stuff to be like, oh, I'm so fancy of like IPv4 address scraping. You're just scraping IP addresses. Like, sometimes the naming gets in front of the skis of what we're actually doing. You know what I mean? I feel like some of the mystique of engineering is just like, oh, okay, S3 buckets, Lambda functions, interesting. Like, you don't know what that means unless you know what it means, unless you're in the club. So I feel like this is kind of one of those pretentious things of like, well, this one's per functional programming and this one's imperative. Well, they're the same thing. You're achieving the same. I'm breaking stuff. Okay, so the important distinction is that the functional example, we never change the value of the car variable. Got it. Okay, so that's the distinction here. We just compose functions that return new values. But again, like when all this code's deployed on the servers nowadays that are nice enough and have more RAM than God knows, the people who, than the computers in 1980, than the people who freaking flew the spaceship, right, to the moon. Does this level of memory change like the performance of every? I feel like technology is getting so far ahead that some of this design stuff, I don't know. We're gonna learn. I'm just venting my frustrations from a DX standpoint of like, I feel like sometimes people got such a stick up their own ass that they're like, I went anti-PG there. I knew I was gonna do it. I stuck with it. But I feel like sometimes that's a bit of software engineering. It's like, no, like, Okay, enough of trash in the space, because I'm part of the space. I'm taking a dump in my own house at this point. But okay, so doc to doc. So in this course, we're working on doc to doc, a command line tool for converting documents from one format to another. If you're familiar with pandoc, the idea is similar. Assignment: complete the stylized title function. It should take a single string input, or as an input, and return a single string as an output. The return string should have both the title centered and a border added. Okay. So up here, so we have used the provided functions, center title and added border. So I imagine we are just going to return, right, something like this, some nested deal of these two. So we'll center the title first, I imagine, and then we'll add the border second, I suppose. And where? With the document. So let's see if that'll work. Pass, sweet. Maybe. Okay, so all hard-headedness aside, I'm going to do a little bit better of a job keeping my mind open on this. Maybe there's a lot of advantages to programming this way, right? But I don't know. Just in my brain, I feel like readability. If we did one more nesting of this, right? Like I would just, let's see. So if we did def, so we'll just say nest function here, just to add a random function here. But really, this would maybe effectively be, some function that we needed to do, but I'm just trying to return the same function just to show all this stuff. So I don't know, like I don't know, like if we did some mutating state in here, I don't know if we did this many nestings, I would honestly break it up. I would say like doc, like with, so I would fall into the victim of just doing it the traditional way of programming, right? Let's see, so doc with center, and then I would center the doc that you would then like add the border, I suppose, right? So doc with border, right? I don't know. I would naturally want to break it up just for like readability purposes. So I don't see the advantages. I love how I said advantageous. Like I don't see the advantages of doing it this way, right? Especially if let's say there's one more function, specifically this like nested function, and this is just a placeholder. So just then it's any sort of function, one more func, right? And then we just pass the doc with border into this, and then yeah, I don't know. To me, this seems potentially more readable, right? You'd see what's going on rather than something like this. Let's go ahead. But I don't know. Maybe there's memory cases. Maybe there's reasons for it. So let's keep learning. Let's keep learning before I let my ignorance get the best of us. Okay, so moving forward. So functional versus OOP. So functional programming is similar to object-oriented programming in the same sense that it's all about writing clean code that is easy to understand and maintain. In the real world, you'll encounter professional developers who are more passionate about functional programming and others who are more passionate about object-oriented. So this is probably me, right? I'm probably on this side of the fence. Both approaches have their pros and cons, and both are valid ways of writing code. So contrary to popular belief, opinion. So I'm curious, just foreshadowing potentially some sort of outcome. Maybe by the end of this section, I'll be one of the guys who's like, actually, this makes more sense over here to go functional programming. So right now, I'm not really seeing an advantage to really even label either or, to be honest. Like I would just say write code that makes sense to your use case. So I don't know. I wouldn't even label it at this point if you were to define one of these different from each other, from that to whatever we showed the time before with the broken out function steps. To me, it's all the same function in my brain. So, but anyway, okay, so contrary to popular belief, functional programming and object-oriented programming are not always at odds with each other. Of the four pillars of OOP, the only inheritance is not compatible with functional programming. So everything else you could do in functional programming, but only inheritance is the only thing with object-oriented programming. So I do like inheritance personally, but maybe there's a way to get around it, I suppose. So functional programming and object-oriented programming are all about writing code. I'm hoping it's this reason. I don't think it is. I think it's writing cleaner code, but I'm going to click this reason because I'm hoping it is. But I really think the answer is actually this. Yeah, see, this is exactly why I wouldn't even care for FP personally. If it's just about writing cleaner code, I don't think this is cleaner. I don't think it's cleaner at all. If it's just some guy who's telling, I don't know. I'm here to challenge all of software's methodologies while I'm in software, because that doesn't seem cleaner. I don't know, just I'm in this space still. So object-oriented programming of inheritance conflicts with auto programming. So, okay, so immutability. Core tenet of functional programming is that the data should be immutable. Here's a part. So once a value is created, it cannot be changed. This is in contrast to mutable data. Got it. So this might be a little bit of the juice of FP versus OOP. So which can be changed after it's created. So why do we care? As a general rule, mutable data is easier to reason about. It's kind of like a pure function. If you know that the value will never change, you don't have to worry about its current state. You see where it's created, and you know it will always be the same. And I love that part. I actually really do love with functional programming. So with like Vue, there's computed functions that I loved. I loved it because you put in some data, It's as good as gold through that computed function. Like that was my bread and butter when I was developing in Vue. It was like, oh my gosh, because it would just produce the same thing every time. I didn't have to think about it. It was as good as importing a JSON document in my mind. It was the best thing ever. So okay, so let's keep reading. So why do we care? Why should I care about this? You know, because clearly I've had some pretty contrarian vocals here, some pretty big beliefs. So as a general rule, immutable data is easier to reason about. If you know that the value will never change, you don't have to worry about its currency. We just read this. My fault. At the end of the day, immutability means fewer bugs and more maintainable code. And I really love those computed functions. So if that's actually what FP is, then let's learn. So because literally working with those computed functions is like, this is amazing. Like it's literally, you don't have to think twice about the function if it's like going to step somewhere, or it was just as good as gold. So anyway, okay, so tuples and lists are ordered collections of values. The difference is that tuples are immutable and lists are mutable. So tuples are immutable, so the data is just what it is. And lists, we can add stuff, we can append stuff, we can remove stuff. Okay, so you can append to a list, but you cannot append to a tuple. You can create a new tuple using values from an existing tuple, running it through a new function, returning something, but you can't change the existing tuple. Good to know. Fun little ring sound. That was fun. Okay, so lists are mutable. So here's an example of us adding some functions or values to a list. Here's an example of us not being able to touch a tuple. So ages and more ages, it just adds them together, kind of like a string would be added. So our string's immutable? Probably not. Probably not. Yeah, I wouldn't think so. Okay, so there's a bug on line 4 in the add doc function. Here it is. Whoever wrote it assigned that documents was a list, but it's actually a tuple. That's a mistake I would not just... Okay, so it's a tuple. Okay, so we have the prefix plus the documents. So new doc, let's see. So documents, boom. So maybe we just need to do this. I didn't read all the directions, but let's just keep running. So, okay, so there's a list on add doc. Whoever wrote this assumed that documents was a list, but it's actually a tuple. Okay, so documents is a tuple right here. Run the code to see the error. So let's revert it real quick. Run the code, boom. Error tuple object has no append. So to create a tuple with a single value, here's what we could do. So documents, new doc. Let me see what's going on here. So print new doc, boom. Okay, so here's our new doc. So we want to, looks like prefix it with 12012. So we kind of want to list it. How to do this? Enter. So I would think we need to increment the prefix then. So length of documents. Oh, I see. So they think this whole thing's a list. Got it. Okay, so it's really not when it's just a, here's the document 012, right? So, but it looks like we cannot get the length of a tuple. Guys, I think this is going to be a multiple thing, maybe. Classes and functions might take a little bit, so let's kind of break this up into 2 bits. So I'll stop maybe after this one, and then we'll get into declarative programming and stuff tomorrow. Okay, so, but let's see. So boom. Where did I mess up right here? Let's see, length of documents. Boom. Okay, so we're back in it. Where did I mess it up? Oh, I need to get rid of this. And let's see. Boom. Okay, cool. Okay, so we're back. So we have 0, 1, 2. It's what we're expecting. Hello there, is it? So the tuple object has no append. So I just imagine we need to prefix, right? It's going to be plus equals 1. We can only do that with an integer, not a string. So we really don't need the length of documents. We could actually just start this at 1, I imagine. Unsupported type, integer for string. Okay, so these tuples are all new space for me. So I feel like a child. Just trying to figure this out. Largely because I am. So unsupported operand types plus equals. Oh, that looks like some fun assembly. Integer and string fail. Interesting. So the prefix was actually appended as 0. So maybe they want us to make it an F string, so it has to be a string. I'm sure in the test it's probably supposed to be a string. Yeah. Okay, so this is what we're back at. Now we have 0, hello, and this is what they wanted, just a space here with 0, hello. And what I could do So maybe number, right? Or like page number, right? Length of documents. Maybe we could even just get rid of that page number altogether, or that length of documents rather. And I could just say page number, right? And then we could maybe do some stuff like this. No, see this. I'm object oriented thinking. I'm still trying to figure out object oriented. Like let's get data and then manipulate the data. So that's actually now I'm realizing this is not what we're supposed to be doing. Okay, so I don't know. Let's take a peek, see what they did. So length of documents. Ooh, so plus new doc right here. So what's this? So to create a new tuple with a single value. I still don't understand it though, because if new doc is just the length of the documents, how does this go up in value, right? Like, wouldn't it just be 0 plus the document? So whatever the document title is, and then equals that. Oh, I see. And then it gets reassigned 0 plus the new doc. What's the new doc? 0 plus the document. That doesn't make sense. Okay. Yeah, there's some learning that needs to happen here. There is some learning that needs to happen here. Okay, so let's try to do this proper. So we'll say new doc equals, or what was it? Return new doc plus, or was new doc plus document, right? Document. And I think it was documents equals boom, something like that, right? And we just return the documents. Expecting 0, 1, 2. How you doing, 14? Okay, let me see it one more time. Oh, I forgot the tuple bit. Okay, but we still failed. Okay, so you cannot concatenate a tuple. Why? What's going on? So new doc equals prefix plus document. Documents equals, oh, I got this flipped. Or no, it's documents plus documents equals new doc. Now, I don't really understand functional programming then. So this is a whole other paradigm. I'm pretentious. This is a whole other paradigm. Okay, so let's see. So documents equals the documents plus the new doc. Oh, now what am I supposed to be learning here, right? The immutability of this. So every time we pass in the documents, there's no state being managed here, right? There is no like there is no like page number, right? Or like document number equals 0, right? Like that's what I'm understanding is there's none of that. So first we take the prefix, which is just the length of the documents. Which I still don't really understand how that's making the length different. So we have the documents here. So let me just print this out step by step so I can learn with you guys, right? Or I can at least learn this bit. Maybe you guys are like, I already know this. You're dumb, Ryan. But I do not understand it. I really don't. I'm being honest. So we start with documents at nothing. The prefix is 0, which makes sense to me. The document's like this, but this is where I'm starting to get a little bit fuzzy on it. So the new document is going to be that basically we're numbering the document, right? So giving the new document here a number. So that makes sense, right? New doc. So let's walk through the steps again. Documents come in. Prefix is 0. The new doc is the document plus the hello there. Oh, this is the length of documents though, right? So where's the document? Where is the actual document? Where does the hello there come in? From the document. Got it. Okay. That's what I'm missing too. So we need the document, which is this guy. Okay. So then we have the document plus the prefix, which that's all adding up so far. This I don't understand. So this is where I'm pretty fuzzy, right? So we have the documents that just comes in right here, I imagine, or here. So the documents is nothing, no tuple, no nothing. The prefix is still 0, which is the length of the documents is nothing. So that makes sense. So the length is 0. So we can't get the length of a tuple. Then the new document gets appended and made with the prefix of 0 plus the document name. So that makes sense. And then we assign documents to, this hurts my brain. Why do we assign documents to documents and then the new doc? I guess that makes sense on the later bit, but for the initial bit, that doesn't add up in my brain. Again, like my head isn't making it make sense because in my sense, if this was nothing and this was also nothing, now the new document, oh, there we go. That's why. Okay, so now the new document is 0. Hello there. Got it. And then gets returned, passed back through. Now, okay. That does make a little bit more sense. Okay, so I'm gonna try from scratch now. Let's get it while it's hot, right? So let's see. So prefix equals so an F string. So this is why maybe this is why functional programming is so good, right? Because there is no state mutation here. It's just literally just like works as pure as ever. So that does actually make sense on why functional programming is probably pretty dominant. It actually makes a lot more sense now. But I just, yeah, I guess I've just always like mutated state and figured that's probably it. So okay, so the new document is the prefix plus the document, right? Boom. So that's the new document. Then documents gets assigned to nothing initially, but that's not a big deal, plus the old documents from the previous loop, and then we're going to make a tuple of the new doc. So we have hello there, which is the actual, we just have the period in the wrong spot, not a big deal. Boom, there it is. Okay, so we have hello there, Sonny, how you doing? Functional programming, folks. I guess I got humbled there. That's a live humbling. That's a live humbling, folks. But I'm learning, you know. I think that's the beautiful part of some of it. But I don't know. Still, I need to be, I think, omnipotently convinced that functional programming has its purpose. I would imagine we're learning it probably has its purpose. But just reading some of it, I just did not like this initial bit. Like, why is that better than just up to steps like this? You know. So I'm not unconvinced. I think this actually is probably good evidence of why functional programming makes sense. But I do want to wrap it up here. Configuration file is, I'm not sure, imperative, declarative. Okay, so let's see. Functional programming is declarative. Okay, so we prefer to declare what we want when we want the computer to calculate rather than the details of how to calculate it. Okay, so let's remember that. Then the script does one thing after another is imperative. Not gonna lie, that was a shot off the hip. That was a shot off the hip. So Terraform is a great example of what it means to be declarative. In the most extreme sense, Terraform is infrastructure as code. IAC is great. It allows you to declare which cloud server resources you want to create. And Terraform as a tool will worry about the exact steps to get there. Here's an example of an AWS EC2 server. Sick. Sweet. Mucked around with a few of those. I've mucked around with a few of those. Now we're speaking my language. Okay, so scripting is imperative. Why? When scripting, we write out the exact step-by-step implementation details. Okay, let me cruise on through. I suppose it's maybe not too much more between. Yeah, I thought actually it'd be a lot longer of a deal. So let's cruise on through. Let's just keep cruising. Okay, so functional programming probably pretty lightweight then. I imagine if it's just like this pure function that you know exactly the outcome of it, probably a little bit different than OOP. So that is kind of cool. It's a tool belt or tool on the tool belt. So let's keep reading. So it's math. Functional programming tends to be popular amongst developers with a strong mathematical background. After all, a math equation isn't procedural. It's declarative. For example, take the following math equation. Average equals this, sigma x over n. It looks scary, but the Greek E symbol is just a Greek letter for sigma. It's used to represent a sum, which just means the sum of all numbers in the list x. Next, to calculate an average, we want to divide by n, which represents the number of elements in that list. Okay, so this math equation is a declarative way of writing the average list of numbers. Here's how some imperative code does the same thing. So we go through nums, we append the nums to the total, and divide the total by the length of num. Okay, that makes sense. Functional programming, interesting. We do it a little different. We just sum nums, divide by length of nums. Okay. This is starting to add up a whole bunch more because my buddy Chester, he writes functional programming a lot of the time, and he uses infrastructure as code. I actually had a lunch with him the other day, and he broke down why infrastructure as code is just brilliant. Because I'm building this huge backend where I have to have like all these functions and step functions that handle each other, cleanup functions and atomic functions that handle multiple transactions, all this stuff. And he's like, dude, infrastructure as code just handles it all for you. It's like, oh my gosh, dude, you're on a whole different ball field. So this makes a lot more sense because that is exactly how Chester. I've seen his code with my own eyes, So here we're not keeping track of state. The total variable is just the first example is stateful. We're simply composing functions together to get the result we want. And I do this with React components on the front end, which is really, really, really helpful. Not only from like the actual math JavaScript standpoint, but you can actually do this with the components. You could stash them in what I always called template functions, but I guess technically it's functional programming with JSX, so that's kind of cool. But anyway, so assignment. In the Word document conversion, we sometimes, that's just me covering up, just being like, wanting to be like, guys, I promise I'm not stupid. I promise. Okay, so anyway, so in the world of document conversion, we sometimes need to handle fonts and font sizes. Complete the get medium font size function. Given a list of numbers representing the font sizes, return the median font size. If the list is empty, return none. Okay, so let's just go ahead and handle that first. So if length of font size equals 0, we'll just go ahead and handle the as a guard clause. Initially, return none. Boom, so that was handled. And then let's do the rest. Okay, so given the list of numbers representing font sizes, return the median font size. If the list is empty, return none. If the list has even number of elements, return the average of the two middle elements. Interesting. So get the index of the middle element is this. Your code should not use any loops, mutate any variables. It's okay to create new ones. Got it. Okay, so let's do this. Let's do this. So if the list is empty, return none. So check, we're there. If the list has an even number of elements, so if length of font sizes, let's see, is modulo 2 equals 0. So that's even. Let's do something. We want to get return the average to, so return, let's see, we want floor division of the middle numbers. So interesting. So font sizes, is that the middle numbers here? Font sizes, potentially. So return the average of the two middle elements. So why is it two middle elements? So this would be the index of them, right? So let's see. So print, I want to print this out and see what it is. Huh. Interesting. Let's go ahead and do some of this, right? So print, boom. So here's expected actual none. We don't have any font sizes coming here. Right here. So expected this. So basically we want to get 11 and 16, I imagine. And what I could do is say print font sizes divide by 2, boom, or floor division by 2. But that just gets the index. So really what I should do is do that by that. So maybe that'll work. Nope, still doesn't do the right deal. Why? What about this? No? Okay. All right, so this is tough, folks. So, okay, so here is an example of expected. Here we got none. It should be none, right? If the list is empty. Why did it return none? There's just a list here. Expected 12. This is a bit challenging, right? This is just learning the fundamentals. This is just juggling with the third hand for the first time, you know? Okay, so use sorted functions. So maybe we want to sort the list, right? Oh, I guess that would make sense, right? So sort the list first, so we could actually identify the median. Then we could take the length of the list. Still don't understand the indexing bit of it. So we sort the list, right? So sorted equals this, right? Sorted list. We can assign variables, we just can't mutate them, right? So we have the sorted list, which is still the same length of the font sizes, so it doesn't really change if we get the length of sorted list or the length of font size is still the same, right? And oh, I see. So if we take the length of the list though now, right? So we say this length divided by 2, is that going to be the middle index potentially? Let's see. Boom, 2. There it is. Fun here. So that would be the middle index. So 0, 1, 2, right? At least we're getting somewhere. But what do we do if the list is even? We have 2 middle indexes. So we need the left middle index and the right middle index. So that would mean if the list is even, then we would just take this -1, I suppose. But this is 12. If length, why did it return none? It should have returned. Oh, I see. We're gonna have to do, separate deals. Okay, so we do have this correct. So middle index is 12. So then if we take the list, Sick. Sorted list with the mid index. That's our answer for this one, for the even bits, but then we need to get the, so boom. If we look at this, pass 12. Sweet. So that got that one. And then we need to get the deal for this guy. So mid index, and then our mid index. So our right mid index would be this one. And then we have our left mid index, which would just be right mid index -1, I think will work. And then we just need to return, I believe this plus this divided by 2, right? Right. Let's go. Let's freaking go. Freaking functional programming, folks. Come on. Who's doing it? There's a lot of engineers doing it, but who's doing it? Who's doing it? Which is better? We're gonna go with functions. You know what I mean? Just to do it. You know. I know the answer is this, but we're gonna go with classes right now too. Just to do it. They're good in their own special ways, right? So if you're unsure to use which one, let's read about this actually. So I often run into new developers after learning about classes, want to use them everywhere. This guy, right? So they assume that because they learned about functions first, functions are somehow inferior to classes. Agree. So they're just different, but they're both tools. They're good at different things. So should I use functions or classes? This is a personal take, but I think it's a good rule of thumb. If you're unsure, default to functions. I typically find myself only reaching for classes when the data or behavior I'm trying to model fit naturally into a class-based approach. So I engineer very, very object-oriented. That's just how I think of most things. I don't really look at the functional stuff. I'm just always like, what does this look like in a structure of data? That's how my brain works, right? So I found this to be often the case for things like game simulations and GUIs. Classes encourage you to think about the world in a collection of objects. Agree. So objects model behavior, data, and state together in a way that draws boundaries between instances of things. Functions encourage you to think about the world in a series of transformations of data. So this is probably actually my weak point, which is great that we're learning it. So functions encourage you to think about world of a thing of data, because now when I'm interacting with these objects, I want to make sure that it's like pure interactions with these objects. So that's where functional programming makes sense. So for example, a function might take the state of a chessboard and a move as input and return the new state of the board as an output. So which is better? They're both good in different ways. So which encourages you to break down problems into instances of stateful things. Instances of stateful things. Well, classes, they do store state, but functional, as they're saying here, we would return the state of the chessboard. So I'm going to go with functional. Of course, it was classes. Of freaking course it was. But that's a bit about functional programming. We just cruised right through. Oh, you know what? That was just the first chapter. That was just the first chapter of functional programming. Oh my gosh, we have like 10 more chapters. Oh my gosh. Oh my gosh. I was like, that was like the best freaking little, like, got what I needed. Now I know when to deploy it. Now I know when to employ functional programming. Holy crap. We still have freaking 10 more chapters to learn about functional programming. So golly, we're in for a treat. Okay, so I will see you on the next one, because I've got to run at 5 a.m. in the morning with the boys. We're running like 5 miles. These guys are nuts, and I'm like struggling to keep up. I'm doing my best, but it is tough to be honest. But awesome. I think that was a very fruitful episode, and certainly for me, and learning a bunch more about the functional programming. So makes sense. Oh, look at this. Look at this. Lambda functions. I'm just saying, it's going to be a good one. It's going to be a good one on the next one. I will see you there. Cheers.